While making devices, you follow proper clean room protocol. That makes the difference between device working and not working. Contamination and cleanliness are the key to making your device work. In theory it may work, but you may not be able to make it work unless follow proper procedure. It's not just about operating equipment. The reason is that whenever you deposit a thin film on any material, whether you like it or not, there is always some native film that is there deposited on it, right, because of oxygen in the environment. So that is one thing. The other thing is there is also a lot of contaminants on it. At all times, we are outgassing body odor, a lot of these chemicals, and if you are working with silicon wafer, where do all these organic molecules end up? They end up on the surface of your wafer. And if you are trying to deposit a film, the film quality depends on what surface the depositing film sees. So these micro or nano contaminants can severely affect the film properties, and it's almost like invisible, right? You don't know what has happened, but between a good user and a not so careful user doing the same process, one will grow great films and the other wouldn't be able to make films at all. And that's why all these devices, all the semiconductor industry operates inside a clean room and with very stringent protocols. And that's the reason, because small changes can affect your device. In fact, if you go to an Intel fab, even the color of the paint and the brand of the paint that they use in all their fabs is all the same. It's all gray, and that the reason is compatible with their clean room process. So that's why they go with it. So people go into lot of effort to make sure that very few contaminants or known or that is kept under control. So that is there to do reproducible research. Of course, dust itself has a problem. Dust itself causes a problem, but that dust is not the only problem, right? There are other problems cause your device to fail. So if you follow proper clean room protocol, those things won't happen. So that's very important. So what is a clean room? Typically clean rooms are seen in pharmaceutical manufacturing and semiconductor manufacturing. There are slight differences between the two, but the idea is to have a very low contamination environment. So clean room is a controlled environment which has a low contamination. So very small number of dust particles, airborne particles, chemical vapor etc. So it's not just dust, all these things are also very critical, right? Clean room is specified by number of particles per cubic feet for a particular size. So when I say something is class 100, so it means a room with less than 100 particles per cubic feet equal to or larger than 0.5 micron. So that's a class 100 clean room. You may have heard about PM 2.5. It's a similar specification. It's for air, number of particles equal to or larger than 2.5 micron. That's your PM 2.5 number. Usually for Delhi, it is in few millions when the pollution is down. When the pollution is up, it's probably in few billions. It is a whole ISO specification, right? So this is only a shorthand, but this also specifies what is the number of particles greater than per cubic feet of 0.3 micron, 0.2 micron. Also there is specification on these organic contaminants, invisible chemical vapors that you can't see, all those things are there in the specification. So we follow this ISO specification. Usually this is inside benches, and this is usually inside robotic environment. So industry operates here. Your latest 2 nanometer or 5 nanometer technology would be operating here. So there, of course, humans are not permitted at all. So it's all robot driven. Okay, so how does a clean room operate? Of course, you have a very good AHU which constantly takes in air and filters it out, right? So there's you're recirculating air as well as taking air from outside. So we know, everybody now knows about air purifiers, how they operate, right? You circulate air through HEPA filters. That's what's happening here. In fact, so these are industrial scale HEPA filters, HEPA, ULPA, series of filters. So one is, of course, you constantly filter it out. So if you are putting in clean air, and it never happens that, so this diagram is a very nice diagram. It's not that you can totally evacuate all the dust. So if somebody is doing any activity, dust is constantly being generated, dust or these particles. So what you have is this dilution effects. You are doing this clean air pumping, and this person is generating, so you have a sort of an equilibrium position. So that's why this person is very important also. So if he starts to cough and sneeze, suddenly no HEPA filter will be able to, no good AHE will be able to maintain a clean room environment. So that's why we advise, for example, if you are sick or sneezing or coughing, don't come inside the clean room. Okay, so one is this effect. The other is this piston effects, which is because of laminar airflow, and particularly I think in the class 100 you have this. So this is like a broom, so it's like a jhadu, whatever, it's the airflow itself is carrying away the dust. That is what is causing, bringing you this ultra clean environment. So this is just an introduction to all the tools that we have inside. So this is for the class 100 clean room. So class 100 clean room has a E-beam lithography, maskless lithography. So these two tools are inside the class 100 clean room. Everything else are IEPCVD, E-beam evaporator, mask aligner, sputtering. So all these are in the class 1000 clean room and more, right? So we have wet bench, thermal evaporator, wire bonder dressing. So maintaining clean room quality is a shared activity. Everybody has to follow, otherwise everybody's devices will get affected. So that's why this user training, it's not just a matter of my devices. One user affects all the users. So all users have to be trained and follow. Lot of equipment is delicate and precisely calibrated, right? You will see, especially these nano positioners and all, with time, if it's in a clean room environment, it will be, it will keep running smoothly. Otherwise, you will see unseen problems. Similarly, lot of vacuum equipment is very sensitive to humidity. So the humidity inside a evaporation chamber is high, then suddenly you will see that the pump down time has increased or it will not pump down. Small changes in humidity can affect the process a lot. So one is, there are two aspects to this training. One is to protect the equipment from you. The other is to protect you from the equipment, which is the safety part, right? So sometimes PCVD or LPCVD in some clean rooms, or even epitaxial growth in silicon, when you use doping, you use gas phase doping, uses phosphine and arsine. So of course we have safety protocols and alarms and things like that, and the system is designed in a way that user is not exposed and things like that. But at the same time, you have to know what to do in case of an emergency. So that is the safety training, right? Especially also not just gases but also chemicals. Paper also sheds particles. So that's why I think even in a clean room you are not allowed to bring paper inside or any kind of cardboard or bare wood. So usually we have, if you need to write something, there is a special paper that we have, clean room paper and clean room ink, which with that you can write. Any sort of drilling, sawing, sanding, all those things. So these things are obviously not permitted. What kind of particles are we looking at? We are looking at very, very small particles, something that you cannot see, right? Everybody knows PM 2.5 in Delhi. You can't see those particles, but you can feel the effects on your lungs. Similarly, you can feel the effects here on your devices, right? So it's important to keep this PM 0.5 level very, very low. Okay, so this is some particulate sizes that we see, so or you don't see, right? So a lot of your viruses and all, they are in this 1 to 10 micron range. Tobacco smoke, right? So tobacco smoke is not just a molecular contaminant, because of course you can smell it, but it's also particulate contaminant. So what happens is your lungs have absorbed their tobaccos and they keep outgassing, and they will outgas. So as you breathe out, it will outgas, and they will outgas not just the vapor but other particles as well, right? So of course don't smoke and come to lab. So that's and you can see these particles are very, very small. So your we don't use an N95, we use the normal surgical filter. So they are not good enough to stop that. This is just to show you that we are always and with COVID, everybody knows we are always outgassing viruses, bacteria, particles, particulates. So we need to be careful. Okay, when not everything is explained in a workshop, some things are common sense. So for example, you don't take a wafer and you blow air on it, or you put it close to your mouth, right? So those things should not be done. So most contamination sources, equipment is 5%, room structure 5%, ventilation 15%, people. So we are the biggest source of contamination. Talking about coughing and sneezing, every time you cough or sneeze, so people have actually done these measurements, you are outgassing about 2 million particles in sneeze and around 100,000 particles in cough, right? So all, forget about your device working. So that's one thing that we talk. I always tell my students, one is never to work when you are sick, and the other thing is that the shortest path to device fabrication requires infinite patience. So the more patience that you have, the faster it will happen, because if you take shortcuts, something or the other will go wrong, and then you'll have to start again. If you do each of process step carefully and how it's supposed to be done, following proper clean room practices, you will proceed very fast, right? So I think that's the moral of the story. And this is to show you number of particles you are shedding per minute if you are still, and if you are doing calisthenics. So it goes from 100,000 to about 15 million, right? So the idea is that inside a clean room you minimize your movement. It's not a place that you go and talk to your friend while your process is running. You plan what your experiment is, you go inside, you do it, and you come out. That's it, right? So the reason I am explaining the principle of these things is because I cannot make enough rules, right? So some things are common sense. You don't hold a wafer in front of you and blow on it. So some of these come from your intuition. You have to understand what you are doing and why you are doing, so that you can do repeatable research. Don't plan to go there and figure out what you'll do. So you'll have to plan ahead. So that's not just our clean room, any clean room. Plan every process in excruciating detail. Talk to people if you're not familiar. So understand what parameters, everything that you're doing, then you go inside and do it. So don't try to go inside and don't start where in doubt. So I found good housekeepings are very, very essential, right? It maintains cleanliness, also it puts you in a mindset where you're more organized and things like that. Do not work alone, stressed or not well. Again, going with this, working with patience and slowly. All processes are documented in a logbook. We always maintain a logbook for the equipment, so that we can trace it back to, if something goes wrong, we can trace back what's happening. Mobile phones are not allowed, of course, big source of contamination, common sense, right? So I'll skip these parts. I think tomorrow we'll have a session where we talk about accessing, how to access our facility. So here we'll talk about using personal protective equipment. So again, PPE comes in two forms: how to protect you from the equipment and to protect equipment from you. So one is cleanliness, the other thing is safety. So this is your typical bunny suit. You covered from top to bottom, always wearing gloves, coverall, shoe cover, mask, safety glasses and hood. So you are covered top to bottom, but there is a particular way that you want to. So it's not just wearing this in whatever way you are ensured of a clean thing, right? You have to wear it in a particular way. Why? So I start with wearing a hairnet, and then I wear gloves. Why do I have this particular order? Suppose I wear gloves and then I put on a hairnet. What happens? All that oil has come onto my gloves. Now I'll touch my wafer, it has transferred. So first thing, I'll wear my hairnet with my bare hand, then I'll wear my gloves, right? And then I'll wear my coverall, okay? And then I'll wear my shoes. Why this way? Suppose I wear my shoes first, what's happening? All the dust from my cotton shirt is falling on my coverall or on my boots, and then I wear this. So what has happened? I have transferred that dust So my PPE is not doing the work that it was supposed to do. So you have to wear top to bottom out, and so that the dust falls inside your garment, not outside, right. So suppose I wear a coverall and then I wear my hairnet, what has happened? All that dust is falling on my coverall, and then I wear, right. And then we wear a mask, and then this hood, right. Right. So boot covers go inside the suit. I think this I have already covered. Gown removal procedure is opposite. Why is this? Why are we so particular about gown removal? It's because, in a research facility these gowns are reused. So if you are going in a clean room 5 times inside the day, you are not wearing a new bunny suit every time you are going inside. So you are reusing it. So you want to make sure that you remove it in a way that dust doesn't come in. So suppose I remove my hairnet first and then I remove my coverall. So there is a time when that dust is falling from my hair onto my coverall, right. So generally the order is reversed. In whatever order that you have worn it, you take it off in the reverse order. So that ensures that this problem is not there, right. This hairnet and gloves we throw away, but this thing coverall is reused. You will see that here I am 2 pairs of gloves, one here and one here. Why 2 pairs of gloves? So this pair is optional. So these are for chemical safety. This is for PP. This is to protect against dust, right. This is to provide chemical safety. So these, so when it comes to gloves, the thicker your glove is, more protection it gives you, but the less dexterity you have. So that's why the general purpose gloves are very thin, but if you need any chemical protection, you need thicker gloves. That's why these 2 pairs of gloves are there. Some other things, of course, visitors are not allowed. No books, pencils. If you really need to work, you have to ask for lint-free paper. How do you take samples inside? So you don't take your sample, wear these things and then do it. No. So there is something called a pass box, which is located, which has doors outside and inside, but only one of them opens at a time. So if the inside doors is open, outside will open. If this is closed, only then the outside. So at no point can both doors be open. So you put your sample here before, and ideally, once you go inside, you take a tissue and then you wipe it down with acetone, and so that there is minimum dust. So I'll come to safety now. So there are various emergencies that can happen. Chemical spill is one sort of emergency. Large chemical spill is a emergency. If a gas alarm sounds, it's an emergency. If a fire alarm sounds, it's an emergency. What else? If there is an earthquake tremor, treat it as an emergency. If there is, if the power goes out for more than a minute or 2, you have to treat it as an emergency. Reason for that is power going out can be due to an electrical fault. So if something that can be a fire hazard, right? If there is a sparking, that can be a fire hazard. So that is one thing. The other thing is, lot of these fail safes may not work if the electricity is out. So that's why electricity going off for more than 1 or 2 minutes is to be treated as emergency. What to do in case of emergency? So first thing is, you don't come out through the gowning area, take off your gown, use the proper way. In case of emergency, we don't do that. There are several emergency doors located in our clean room. Also there are some. You get out of that emergency doors, right? Don't worry about your clean room, everything, just get out. So that's what you have to do in case of emergency. Sometimes lot of equipment, so if it's like a chemical spill in some other room that's everybody is evacuating, you have time to shut down the machine. So most machines will have an emergency stop button. So press that emergency stop button if you can. And if you notice an emergency and there's no alarm, you are required to inform the clean room staff and wait for instructions, right? Okay, gas alarm is specific to PCVD. I think not so much here. This is more of a concern because it has silane, arsine, phosphine. These are all hazardous gases. So if they leak, there's a uh, fire alarm here, gas alarm here. So that's emergency protocol. Coming to safety, there have been couple of accidents worldwide in labs, and usually it's the experienced people who get affected. And the reason is why? Because experienced people feel that they can take shortcuts and they need not follow the rules, and that's when these things happen. Beginners usually are very scared, so they take proper PP and they take proper precautions. But experienced people, they feel they can take shortcuts, and that's when things go wrong. So even if you are experienced, follow the beginner's mind. So first rule is wet bench is the only safe place for chemicals, right? So chemists can do things in a test tube, but we don't. Like we don't do in open air like that. All chemistry has to be done inside a wet bench, so that you are not exposed to those vapor fumes, right? So that's the first rule. All chemistry inside wet bench. While working on a wet bench, it is mandatory to wear lab slippers, wear aprons, so these are chemical safety aprons. These are not the coverall. So these are aprons protect you from chemicals. So this is not mandatory face shield, but safety glasses are mandatory. You have to wear proper gloves, and when you start, make sure that the exhaust is functioning. Otherwise, if you are working in a fume mode and the exhaust is not functioning, it's not really working inside. So first thing you have to come in, you have to make sure that if it's not turned on, make sure it's turned on, and then start any chemistry process. Use of gloves. So there are various kinds of gloves. PVC latex, these are your normal surgical gloves. They protect wafers from particles. So these are for cleanliness, but they don't provide you any chemical protection. They have very little chemical protection. In our particular lab, we use nitrile. There are two kinds of it: thin nitrile and thick nitrile. The ones we have are thin nitrile. So our general purpose gloves are here, but not in every clean room you will find these general purpose gloves. Many clean rooms have these ones, right? So they provide some level of chemical protection against solvents, not against acids or bases. They provide some level of chemical protection against solvents. But if you are doing any heavy duty solvent processing, it is advisable to wear two pairs of it, right? So that, or wear a thicker one, so that you have protected. If you are not doing any chemical processing, that's fine. If you are doing anything with acids, bases, HF, things like that, you need to wear Trionic gloves. So they are thick chemical resistant gloves, and if you have to clean up leak or things like that, they are useful. But again, common sense happens. So if you have a leak, don't try to, even if you are wearing gloves, don't try to touch it. These are for your safety, but doesn't mean that this is the only line of safety. Common sense and alertness are sort of as important. So Trionics usually come up to your elbow. They are little uncomfortable, but they provide you good chemical protection. Treat all chemicals as hazardous. So for whatever experiment that you are doing, we advise that you have to read the MSDS of the chemical. MSDS stands for Material Safety Data Sheet. Every chemical that is sold is required to have an MSDS. So even for proprietary chemicals like photoresist or developer solvents, there will be an MSDS. Please, if you are going to the lab, please read these MSDS before going. So, this will have information regarding, one is what acute exposure limits and chronic exposure limits. So what is the, again I mentioned acetone, acute exposure, no problem. You are exposed to every day, but what is the effect of chronic exposure? Over 5 years, if you are breathing in acetone vapor every day, what is the effect of it? That will be there in MSDS. What to do in case of emergency exposure to that chemical, especially very flammable chemicals or aggressive agents, you need to know very carefully what those chemicals are about. Never rub your eyes or face with your hands or gloves. Always add acid to water. We always teach that in high school, but people always forget. Always clean up once you are done. You don't want to keep a beaker full of any colorless or any colored liquid, because the person, you may think it's benign, but the person coming after you doesn't know. Similarly, for minor spills, you need to clean up everything before you leave, because the person, it may just be DI water, but the person coming after you doesn't know it's DI water, right? So chemicals should be in hood. Don't mix chemicals randomly. You have to sort of know what you're doing. Wear appropriate gloves. Okay, sometimes how do you dispose of it? I think in our lab we have an acid waste disposal, so you can pour it down the drain, except for HF. Some chemicals you need to cool before pouring. So in semiconductor processing, a lot of times we use Piranha, which is hot concentrated sulfuric acid, and you can't just dispose it of it like that. So you need to cool it. So in that case, on a sheet or something, write it down. Okay, this is, so that person coming after you knows what it's there, right? What to do in case of spills? So if it's small chemical spill, you can dilute with water, put a spill blanket. If it's big, don't handle it yourself. Staff, inform clean room staff and then do it. What to do if you have a chemical spill on your own, right? If something spills on your body or inside your eye, or what to do. So we have this emergency safety shower located outside the clean room in the corridor. So you have to come and basically pull it, and it will, you'll take a safety shower if it's exposed to you. So again, emergency protocol, don't come out through that. If something has gone into your eye, so this safety shower also has a eye wash station. So what you have to do is you have to, hold down your eyes and flush your eye in that eye wash station for about 4 to 5 minutes. It's going to seem a long time, but actually do it. And with all that water, you may feel like closing your eye, but don't, because that's a matter of your sight. So, and after that you can seek, this is your emergency thing, and then you can do what is it. So there are some rules and regulations. Fluoride solution only used in plastic beakers or Teflon, because HF can etch glass, right? You can, if you leave a beaker of HF and next day you see there's a spill, why has it happened? Because the fluoride has etched through glass. So glass is, so all fluoride has to be done in PP beakers, and generally we don't exchange glassware. So whatever is used for HF, we use for HF. Whatever is being used for acetone, we use for acetone. You don't take one beaker from the solvent bench and put it in the acid bench and use it. You don't borrow beakers. If you're short of beakers, ask clean room staff and they will provide you more beakers, right? So I think this is fine. No contact lenses. So this is very big. So contact lens is not allowed inside clean room. Some chemicals or solvents can cause damage to your contact lens and can damage your eye. So we advise you don't wear contact lens inside. MSDS, I think we have. Okay, these are some hazard symbols that you should be aware of. This is there on every bottle. So E is explosive, O is oxidizing. What happens if you store E and O together? Boom, right? Similarly, you don't store flammable and oxidizing together. Toxic, all these chemicals, you have to be very careful how you dispose it, right? Also, I think MSDS, I would say also be aware of what the chronic exposure effects are. One is acute exposures, other is chronic exposure. You want to be very careful that you are not exposing, that chronic exposure is also minimized, right? I think this is done. This is the last part. I think HF we have to be very careful about. So, of all the chemicals that are in the clean room, HF is particularly dangerous. Even dilute solutions are dangerous. Why? That fluoride ion has very lot of affinity for calcium, so it will cause decalcification, and so 49% HF will decalcify your bone, and typically you have lot of pain as well, red discoloration with whitish blister, and the fluoride can go through the bone. So usually if you have exposure to this, people have to amputate, otherwise the fluoride goes through your bones and it will eat more of your body parts. 20% HF is less than 20% is actually more dangerous. Why? Because the symptoms takes up to 24 hours to appear. By that time the damage has already happened, and once it's gone in, then it will start to eat, and at that point you can't do much about it. So it's already gone inside. So symptoms you may not notice on exposure, but you may notice later on. So that's the problem with this. So even if you suspect something wrong, then take the right precaution, and I'll tell you what to do. So if you've exposed yourself, I think wash with large amounts of flowing water and rub in calcium gluconate gel. So this gel, we have that in NRF. So remember, fluorine has affinity for calcium, so exposure, this will sort of take away that, and after that seek medical attention. Right? If it happens in the hostel, put some chalk or lime that has calcium in it. Not as good as this, but it will suffice in a pinch. Okay, we have other chemicals, sulfuric, nitric. So all of these are, of course, you've worked in high school labs, but here it's a fuming nitric acid, 98% sulfuric acid, boiling phosphoric acid for some H's. So these are to be handled very, very carefully, and of course these all we know, but you have to do this in a wet bench. And when you operate in a wet bench, you don't put your face inside the bench to see what's happening. It's across the barrier, so only your hands go in. So in case anything happens, only your hands are exposed, and there you are wearing gloves. So that's how you minimize exposure. Long-term exposure, you have to understand what the effects of these chemicals are. I think they are done. I think I'll come to photoresist. That's the other thing. People think photoresist is not benign, but photoresist can have it's a flammable material, so you have to handle it carefully. The other is that exposure to it day in and day out can cause problems, so you have to minimize, so that you're not breathing in photoresist solvent or photoresist thinner. So that thing is, so you have to wear protective gear when dealing with photoresist. Okay, I think I'm done from this talk.